Okay, so let's pick up with dividing. Sorry about that. Pick up with dividing polynomials here. And basically what we learned yesterday is we want to turn this to a multiplication problem right away. So we are going to just recopy this, change to multiplication, and invert this one. This is our move to turn it into a multiplication problem. All right, at this point, we are ready to turn this into one single fraction where we factor everything. These are all actually pretty easy factors here because, one is just one. We don't need to bother writing that. But this is just a equals 1. So factors of -6 that add to 1 would be 3 and -2. So t plus 3, t minus 2. This one, difference of squares. So t plus 2, t minus 2. And this one, another a equals 1 factoring. So factors of 9 that add to 6 are 3 and 3. So t plus 3, t plus 3. Sweet. So we are fully factored. At this point, I always take a little pause and I write down my restrictions. Now be careful here because this is in a denominator. This is in a denominator. And when you flip it, so is this. So we actually have to look at all three of these pieces. So it's everything but the 1. So it's literally everything here is a restricted value. Every 0 from this. So that would be -2, +2, -3, -3 again, -3 again, and +2. So there we go. 3 restrictions in this case. Okay, simplify things out. We have a couple canceling out to 1s here. And remember, when I say cancels out to 1, that's important because when you divide these, you get 1. So it does still just have 1 on top. There was a 1 there. It's always there. And then we'd have just t plus 2 and t plus 3 in our denominator. And there we go. That'd be our simplified answer. All right. I also threw on here just a straight up multiplication. Today you're going to see a worksheet with just sort of a mixture of a bunch of problems and of all adding, subtract, or not adding, scratch that. Multiplying and dividing, simplifying them, and doing everything from there. So this one, nothing to factor here. There's no pluses or minuses anywhere. This is just consolidating and then seeing what we can reduce. So 4 times 7 would be 28. X to the first times x to the third is an x to the fourth. Looks like we're going to have the y squared and the z squared. So that's going to be our numerator. Down here, 3 times 6 is 18. We're going to have an x squared, a y squared, and just a z. Cool. So restricted values, actually each of these is just going to not be able to equal 0 because if any of these were 0, it would make the whole denominator 0. So yeah, there's multiple variables, but it doesn't really change how difficult the problem is. Just, none of those values can be 0. All right, so what does this reduce to? 28/18, those are both divisible by 2, so this would become 14/9. Okay? And then with all my variables here, x to the fourth divided by x squared. So these 2 will eliminate 2 of those, knocking it down to an x squared. Y squared divided by y squared just becomes a 1. A z squared divided by a z is going to eliminate 1 of those, leaving you with just the z. Okay? And there we go. Looking good. Okay? So you're going to see a bunch of this today. I think I got 13 different simplifying problems. I got the key for you. You can work them out, see if you're understanding this stuff pretty well.